Hey guys, and welcome to the school station. Today's video we're going to be talking about chemical equations. This is from the AQA GCSE Chemistry 91 paper, and this is the unit Atoms, Bonding and Moles. Today's video I'm going to be talking about chemical equations, the two ways of presenting it, and we're also going to be talking about how to balance equations. So let's just get right into the video. So first of all, we actually have to think about what a chemical equation actually is. So chemical equations show the reactants, the substances that you start with, and the products, the new substances made in a reaction. So when you're doing a reaction, we always obviously have things that we start with, and those are the reactants. And then when we actually have finished the reaction, we have these products that are the new substances made. Therefore, we actually have to know how to present these chemical equations so we can actually know what we get out of a reaction. So there are actually two ways of presenting a chemical equation. The first way is actually through a word equation where it shows you the reactants and the products. So it's super simple. It just gives you through the words what you get in the beginning and what you get in the end. And a simple equation, however, also shows the reactants and the products, but it actually also shows you how much of each substance is involved in a reaction. And this will really help later on when you're balancing equations, and you'll be able to know more about this. Again, however, a simple equation sometimes is not balanced, which is why you get these questions of balancing equations, because according to the law of conservation of mass, everything has to be equal. So this is why we have to balance equations. But we're going to be talking about this more later on. So just to go through an example of a word equation is methane plus oxygen turns into carbon dioxide plus water. It's super simple. You just write it down, and it's just really easy to write down a word equation. But a simple equation can be a bit harder to learn, but again, it can be the same thing. We have nitrogen plus hydrogen turns into hydrogen, but as you guys can see, there are smaller numbers next to the symbols, and that's just showing you how much of each substance is involved in it. So in this reaction, we start off with 2 nitrogen atoms and 2 hydrogen atoms, but it turns into 1 nitrogen atom and 3 hydrogen atoms. Now you guys might be wondering that, well, wait a minute, shouldn't we be having 2 hydrogen atoms and 2 nitrogen atoms in the end of the reaction as well? So this is actually something we're going to be talking about later on in this video. So now I'm going to be talking to you guys about the law of conservation of mass. So this law actually states that the total mass of the products formed in a reaction is equal to the total mass of the reactants. So again, as I said earlier, in this example over here, we have 2 nitrogen atoms and we have 2 hydrogen atoms. So what we're actually meant to be getting is, again, 2 nitrogen atoms and 2 hydrogen atoms in the end. But as you guys can see, this is not the case over here. But the law of conservation of mass does say that the products formed in a reaction is equal to the total mass of the reactants. So therefore, whatever you start with, it has to be the same in the end. Well, the reason why sometimes the law can sometimes appear to be broken is because the reactions may be carried out in open containers such as test tubes. So what can happen is that, for example, nitrogen and hydrogen are both gases. So if this reaction was actually happening in a place where they were actually putting these gases in test tubes, it can actually kind of make the law appear to be broken. But what really happened is that maybe the nitrogen actually got released into the air, and this is why it doesn't show up over here, and it looks like one atom of nitrogen actually disappeared. But it's actually because the nitrogen was released into the air, which is why this law may appear to be broken. And even for the hydrogen, you guys can see there is 1 extra atom. Well, it's because of the surroundings, because the reaction could have happened in open tubes, open containers like test tubes. So therefore, you have to really understand that it's about how the reaction was taking place as well. And this is why sometimes in reactions containing gases like this one over here, the law can sometimes appear to be broken. So yeah, that could be because the gas is released into the air, but overall we should know that the total mass of the products formed in a reaction is equal to the total mass of the reactants. So since the symbol equations sometimes may look like this, we're sometimes asked to actually balance the equations because we have to follow the law of conservation of mass. So what we're going to have to learn to do is to actually balance equations. So over here we actually actually have a simple equation, but as you guys can see, this is not balanced, because over here we actually have Fe, which is iron, 2 atoms of iron and 3 atoms of oxygen plus carbon, and then it actually turns into only 1 atom of iron and 1 atom of carbon and 2 atoms of oxygen. So therefore, as you guys can see, this equation is not balanced, because the first thing you have to do to actually realize that an equation is not balanced is write down how many atoms each substance has. So iron has 2 over here, oxygen has 3, and carbon has 1, but over here, as you guys can see, iron only has 1, so we can already see that the equation is not balanced. Even again for oxygen, you guys can see before it was 3, but now it's 2, but carbon is still balanced. But even if you just find at least one substance that is not balanced, you should know that this equation is not balanced, and this means you'll have to balance it out. So after you basically, the first step to actually balancing equations is to actually write down what you have already, and then after you've actually counted the amount of atoms, the next thing you have to do is to actually go on and try to balance. And something that you actually have to remember is that you can only add big numbers in front of the symbols. So for example, if we actually have 3 atoms of oxygen and you have 2 atoms of oxygen over here, then if you want to actually increase the amount of oxygen atoms over here to balance it out, then you might have to put a 2 in the front of it, and if we put a 2, it's going to become 2 times 2 is 4, so there's going to be 4 oxygen atoms over here. But again, if we also put 2 over here, we're going to be changing the carbon as well, because the carbon has an invisible 1 over here, so there's 1 carbon atom which is going to turn into 2, so you're just going to have to kind of alter it and do trial and error until you balance the equation. So remember, you can only add big numbers in front of the symbols, which you can basically multiply together to actually get the amount of atoms. If I put a 2 here, I can do 2 times 2 is 4, so I'll get 4 oxygen atoms. So you can only add big numbers in front of the symbols, but you cannot change the small numbers no matter what. So I want you guys to now pause this video and try to actually balance this equation, because I feel like some of you guys may be getting the hang of this, but again, if you don't get the hang of this, you can just continue with the rest of the video. But if you think you can get the hang of it, then pause this video and try right now. Alright guys, so I hope you guys have tried it out. So here is the answer. The answer is that we should be having a big 2 in front of the iron, which is going to actually change it into 4 atoms, because 2 times 2 is 4. So now we're going to be having 4 iron atoms. Over here we should be having 2 times 3 because it's combined together. So 2 times 3 is 6. So we should be having 6 oxygen atoms. And over here we actually added a 3. So that's going to be doing 3 times 1 is 3. So we have 3 carbon atoms in this side of the reaction, which is the reactants. And the products should be that there is, again, we just add a 4 in front of the iron, and that's going to turn it into 4 atoms of iron. And then over here we should have added a 3 just to make it 3 carbon atoms, and 3 times 2 is 6, and that's going to be 6 oxygen atoms. And as you guys can see, if we compare the iron, both of them are 4, so that's balanced. If we compare oxygen, both of them are balanced. If we compare carbon, both of them are balanced. So therefore we now know that this equation is balanced. I know that some of you guys may not be understanding, but I think all this balancing equations is all about trying. So I want you guys to definitely practice this at home, and maybe even ask your teacher if possible, because balancing equations can be pretty hard, but it may come up in your exam. So I hope you guys have actually enjoyed this video, and I hope that this has helped you. What we have learned today in this video is about what a chemical equation is. So obviously a chemical equation, as we have seen, is actually a representation of showing the reactants and the products in a reaction. We also have learned the 2 different ways of presenting chemical equations, which is through a word equation and a symbol equation. And last of all, we also have learned an overview about how to balance equations. So obviously we try to write down the list of how much we have of each substance, and then we try to do trial and error until we actually are able to balance equations. So I really hope you guys have enjoyed this video. Definitely give it a thumbs up and subscribe down below to stay tuned in the school station for free science and maths lessons. Bye guys!